In the depths of space, 13.8 billion years ago, everything that would ever exist exploded into reality from a point smaller than the head of a pin. This was the Big Bang, the moment when time itself began and the universe burst forth in the most violent expansion ever conceived. But what if everything we think we know about cosmic creation is wrong? What if the Big Bang wasn't the beginning at all, but something far stranger? Today, we journey into a realm where the impossible becomes inevitable, where the laws of physics flip inside out, and where the ultimate cosmic mystery might finally have an answer. Prepare yourselves for white holes, the universe's most enigmatic objects that could rewrite the entire story of existence itself. We begin. While black holes trap light forever, white holes blast it outward with impossible intensity. While black holes pull matter inward past the point of no return, white holes reject everything that approaches them. They are cosmic fountains of pure creation, spewing forth matter and energy in torrents so powerful they could birth entire galaxies. Yet, despite being mathematical certainties, we've never definitively observed one. They exist in the shadowy realm between theoretical prediction and observable reality, hiding in plain sight across the cosmic landscape. The equations don't lie. Einstein's field equations treat time as just another dimension, no different from length, width, or height. When you reverse the flow of time in these equations, black holes transform into their mirror image. The event horizon becomes a boundary that nothing can cross inward. The singularity at the center becomes a point of infinite creation rather than infinite destruction. Matter and energy pour outward in an endless cascade of cosmic birth. Think of a black hole as a one-way door leading into a room you can never leave. A white hole would be the opposite, a one-way door leading out of a room you can never enter. Anything trying to approach a white hole would be violently expelled, pushed away by forces so intense they defy imagination. The closer you get, the more violently you're rejected, until even light itself cannot penetrate the white hole's boundary. But here's where it gets truly bizarre. White holes exist in reverse time. From our perspective, watching a white hole would be like watching a movie played backward. Matter would appear spontaneously at the boundary and accelerate outward, carrying energy and information from some unknowable source. The white hole would glow with the light of creation itself, burning brighter than 1 trillion stars as it converts pure nothingness into the building blocks of reality. The mathematics are elegant, almost poetic in their symmetry. Black holes represent the universe's ultimate recycling centers, taking matter and energy and compressing them beyond the point where normal physics applies. White holes would be the universe's ultimate factories, taking something from beyond the edge of space and time and transforming it into the raw materials of existence. Together, they form a cosmic partnership that could explain the deepest mysteries of how our universe came to be. Recent discoveries in quantum mechanics have revealed something extraordinary about the nature of vacuum itself. What we call empty space isn't truly empty at all. It seethes with quantum fluctuations, virtual particles popping into existence and annihilating each other in timescales so brief they exist below the threshold of direct measurement. These quantum foam bubbles represent the universe at its most fundamental level, where the smooth fabric of spacetime gives way to a churning sea of probabilistic chaos. Stephen Hawking proved that black holes aren't perfectly black. They emit radiation through quantum effects at their event horizons. Virtual particle pairs that normally annihilate each other get separated by the black hole's gravity. One particle falls in, while the other escapes as real radiation, causing the black hole to slowly evaporate over cosmic timescales. This Hawking radiation demonstrates that even the most extreme objects in the universe obey the laws of quantum mechanics. If black holes can emit radiation and slowly fade away, what happens to white holes in this quantum framework? The answer might explain why we've never observed one directly. White holes should be fundamentally unstable in our universe. Any matter that falls toward them gets expelled with such violence that it creates a shell of material surrounding the white hole. This shell would eventually collapse back down, potentially triggering the white hole to transform into something else entirely. But instability doesn't mean impossibility. In the extreme conditions of the early universe, when space itself was smaller than an atom and temperatures exceeded anything we can imagine, white holes might not only have been stable, but inevitable. The quantum fluctuations that created the matter and energy we see today might have emerged from white hole horizons, cosmic geysers of creation that operated for brief moments before transforming into more familiar objects. The connection becomes clear when you examine the mathematics of cosmic inflation. In the first fraction of a second after the Big Bang, space expanded faster than light itself, stretching quantum fluctuations to cosmic scales and setting the stage for everything that followed. But what drove this incredible expansion? What provided the energy to inflate a universe from subatomic to astronomical size in less time than it takes light to cross a proton? Traditional models invoke mysterious scalar fields with exotic properties, mathematical constructs that exist primarily to make the equations work. But white holes offer a different explanation, one rooted in the fundamental structure of spacetime itself. If the Big Bang began as a white hole event, the violent expulsion of matter and energy would naturally create the rapid expansion we observe. The universe wouldn't need exotic fields or fine-tuned parameters. It would simply be the inevitable result of a white hole's explosive birth. Consider the horizon problem that has puzzled cosmologists for decades. The cosmic microwave background radiation shows that regions of space separated by vast distances have identical temperatures, despite being too far apart to have ever exchanged energy. How did opposite sides of the universe achieve thermal equilibrium if they could never communicate with each other? Inflation solves this by proposing that these regions were once close together before being stretched apart by exponential expansion. But a white hole origin offers an even more elegant solution. If all the matter and energy in our observable universe emerged from a single white hole event, then everything started at the same temperature by definition. The cosmic microwave background's uniformity wouldn't require fine-tuning or exotic physics. It would be a natural consequence of everything sharing a common origin point in a white hole's explosive emergence. The flatness problem presents another puzzle. Our universe appears to be geometrically flat, balanced precisely between eternal expansion and eventual collapse. The probability of achieving this exact balance through random initial conditions is virtually zero. Yet here we are, living in a cosmos that sits exactly on the knife's edge between these two extremes. Inflation explains this by stretching space so much that any initial curvature becomes undetectable, like inflating a balloon until its surface appears flat. White holes provide an alternative explanation that's even more compelling. The violent expulsion of matter and energy from a white hole would naturally create flat, space-time geometry. The tremendous outward pressure would flatten any curvature, creating exactly the kind of universe we observe. No fine-tuning required, no exotic scalar fields needed. Just the inevitable geometric consequence of a white hole's explosive birth. But the most intriguing connection lies in the nature of time itself. The Big Bang represents a moment when time began, a boundary beyond which our physics cannot penetrate. We can trace the universe's history back to fractions of a second after this moment, but the moment itself remains shrouded in mathematical infinities and physical impossibilities. Our equations break down completely, leaving us with more questions than answers about the ultimate origin of everything. White holes exist in a strange relationship with time that might resolve this paradox. From the perspective of an outside observer, a white hole appears to be eternally expelling matter and energy. But from the perspective of the matter being expelled, the process happens instantaneously. This time, dilation effect means that a white hole could expel the entire contents of a universe in what appears to be a single moment to outside observers. while the expelled matter experiences a normal flow of time. This temporal paradox might explain why the Big Bang appears instantaneous from our perspective, while containing enough complexity to create 13.8 billion years of cosmic evolution. We might be living inside the expanding wavefront of matter expelled from a white hole, experiencing time normally, while the entire process appears instantaneous to observers outside our cosmic bubble. The energy requirements for such an event stagger the imagination. Creating a universe requires converting nothingness into the mass energy equivalent of hundreds of billions of galaxies, each containing hundreds of billions of stars. The total energy content of our observable universe approaches values so large they challenge our ability to comprehend them. Where could such enormous amounts of energy possibly come from? Quantum mechanics offers a tantalizing hint. The uncertainty principle allows energy to be borrowed from the quantum vacuum for brief periods, provided it's paid back quickly enough that the universe's accounting system doesn't notice the violation. Larger energy loans require faster repayment, but there's no absolute limit to how much energy can be borrowed if the loan period is sufficiently brief. A white hole event could represent the ultimate expression of this quantum loophole. If a white hole could expel the energy equivalent of an entire universe in a time period shorter than the quantum uncertainty threshold, it might be able to create something from nothing without violating any physical laws. The energy debt would be paid back so quickly that reality itself wouldn't have time to object to the transaction. This quantum sleight of hand opens doorways to possibilities that stretch the boundaries of rational thought. If white holes can manipulate time and energy in ways that seem to violate causality itself, then perhaps they don't just expel matter and energy randomly. Perhaps they operate according to principles we haven't discovered yet, cosmic engines designed with a purpose that transcends our current understanding of physics. The evidence hiding in plain sight across our universe suggests something extraordinary about the nature of cosmic creation. Astronomers have discovered structures so vast and organized they shouldn't exist, according to conventional Big Bang models. Galaxy filaments stretch across hundreds of millions of light years, forming cosmic webs of matter separated by enormous voids. These structures appear to have formed too quickly after the Big Bang, requiring organizational processes that exceed what gravity alone could accomplish in the available time. But if these structures originated from white hole events rather than gradual gravitational assembly, their existence becomes not just possible, but inevitable. White holes wouldn't randomly spew matter in all directions. The mathematics suggest they would create coherent streams of material, cosmic rivers of matter and energy that naturally organize themselves into the large-scale structures we observe today. The cosmic web isn't the result of billions of years of slow gravitational evolution. It's the fossilized imprint of white hole eruptions that shaped the universe during its earliest moments. Consider the mysterious dark energy that comprises 70% of everything that exists. This invisible force pushes galaxies apart with ever-increasing strength, accelerating cosmic expansion in ways that seem to violate energy conservation. As space grows larger, more dark energy appears to fill the void, creating a cosmic acceleration that grows stronger over time. Where does this additional energy come from? How can the universe create something from nothing on such vast scales? Traditional explanations invoke quantum fields that permeate empty space, mysterious entities that exist primarily in mathematical equations rather than observable reality. But white holes offer a more concrete possibility. If dark energy represents the ongoing influence of primordial white hole events, then its mysterious properties become natural consequences of white hole physics. The energy doesn't appear from nowhere. It's being continuously expelled from white holes that exist beyond the boundaries of our observable universe. These distant white holes would be invisible to our telescopes, located in regions of space so far away that their light hasn't had time to reach us. But their influence would still affect our cosmic neighborhood through the expansion of space itself. Dark energy wouldn't be a mysterious field with arbitrary properties. It would be the detectable signature of white hole activity occurring beyond our cosmic horizon, evidence of creation happening on scales we can barely imagine. The accelerating expansion of space creates another puzzle that white holes might resolve. If dark energy continues to strengthen over cosmic time, it will eventually overcome all other forces holding structures together. Galaxy clusters will separate beyond recognition. Individual galaxies will lose their ability to hold onto their stars. Even atoms themselves might be torn apart in what cosmologists call the Big Rip, a future scenario where expanding space becomes so violent it destroys every bound system in the universe. But this catastrophic ending assumes dark energy behaves like a simple cosmological constant, maintaining steady properties across cosmic time. White holes suggest a different possibility. If dark energy comes from white hole activity, then its strength should vary depending on how many white holes are currently active beyond our cosmic horizon. As these white holes age and transform into other objects, dark energy might weaken rather than strengthen, changing the universe's ultimate fate from inevitable destruction to something far more interesting. The transformation of white holes into familiar objects provides another piece of this cosmic puzzle. White holes can't remain stable forever in a universe filled with matter and radiation. Eventually, the shell of material that accumulates around them would collapse inward, potentially triggering a phase transition that converts the white hole into something else entirely. The most likely outcome would be the formation of a black hole, creating a cosmic cycle where white holes birth matter and energy that eventually feeds back into black holes. This cycle suggests the universe operates like a vast recycling system, where matter and energy flow from white holes to black holes and potentially back again through processes we don't yet understand. Black holes might not be the ultimate endpoints of cosmic evolution. They might be cosmic seeds, waiting for the right conditions to transform back into white holes and begin the cycle anew. The Big Bang wouldn't be a unique event that happened once and never again. It would be part of an eternal cosmic rhythm, a universal heartbeat that creates and destroys and creates again across timescales that dwarf the current age of our universe. Recent discoveries in gravitational wave astronomy have revealed something extraordinary about the nature of space and time. When black holes merge, they create ripples in space-time itself that propagate outward at light speed. These gravitational waves carry information about the most violent events in cosmic history, allowing us to observe phenomena that remain invisible to conventional telescopes. But gravitational waves also provide a new way to search for white holes, objects that should create equally distinctive signatures in the fabric of spacetime. A white hole's violent expulsion of matter and energy would generate gravitational waves unlike anything produced by known astrophysical objects. Instead of the characteristic chirp pattern created by merging black holes, white holes would produce signals that appear to run backward through time. The gravitational wave detectors that have revolutionized astronomy might already have observed white hole events without recognizing them for what they are. The challenge lies in distinguishing genuine white hole signatures from instrumental noise or previously unknown astrophysical phenomena. White hole gravitational waves would carry information about the creation of matter and energy rather than their destruction, encoding details about cosmic birth processes in patterns of space-time distortion. Learning to read these patterns could unlock secrets about the fundamental nature of existence itself, revealing how the universe creates something from nothing through mechanisms that operate beyond the edge of observable reality. But perhaps the most profound implication of white hole physics lies in its relationship to consciousness and observation. Quantum mechanics reveals that the act of measurement plays a fundamental role in determining which possibilities become actualized from the quantum realm of pure potential. If white holes represent cosmic measurement events, moments when quantum possibilities collapse into classical reality, then they might be the universe's way of observing itself into existence. This connection between white holes and quantum measurement suggests that consciousness might play a more fundamental role in cosmic evolution than previously imagined. The universe wouldn't be a mechanical system grinding through predetermined motions. It would be a vast information processing system, using white hole events as cosmic moments of self-awareness that collapse quantum possibilities into the matter and energy we observe around us. The implications stretch beyond physics into philosophy and metaphysics. If white holes represent the universe becoming conscious of its own potential, then every particle, every star, every galaxy becomes part of an enormous cosmic mind awakening to its own existence. We wouldn't just be observers of the universe. We would be the universe observing itself, temporary concentrations of cosmic awareness, participating in an ongoing process of self-discovery that began with the first white hole event and continues through every moment of conscious observation. The mathematics of white hole formation reveals something extraordinary about the nature of reality itself. Unlike black holes that form from gravitational collapse of massive stars, white holes would emerge from the quantum vacuum through mechanisms that exist at the very foundation of spacetime. These aren't gradual processes that unfold over cosmic ages. They represent instantaneous phase transitions, where the fundamental structure of space and time reorganizes itself in ways that create rather than destroy. Imagine the quantum vacuum as a perfectly calm ocean surface hiding tremendous activity beneath. Virtual particles constantly emerge and annihilate in the depths, creating a foam of probability that underlies all existence. Under normal circumstances, this quantum activity remains hidden below the threshold of observable reality. But under extreme conditions, when energy densities approach the Planck scale where quantum gravity effects dominate, this hidden realm can break through into our familiar world of matter and energy. White holes would represent these breakthrough moments, cosmic geysers where the quantum vacuum erupts into classical reality. The transition wouldn't be smooth or gradual. It would be explosive, violent, and utterly transformative. In a region smaller than a proton, the accumulated potential of quantum fluctuations would suddenly convert into real matter and energy, expanding outward at velocities that approach the speed of light itself. The energy release would dwarf anything we observe in the modern universe. A typical white hole birth event could exceed the combined energy output of all stars in a galaxy cluster, concentrated into a space-time region so small that our concepts of distance and duration lose all meaning. The explosion wouldn't just create matter and energy. It would create the space and time necessary to contain them, bootstrapping an entire cosmic domain into existence through pure quantum mechanical willpower. But white holes don't just solve the mystery of cosmic origins. They revolutionize our understanding of causality itself. In our everyday experience, effects follow causes in a predictable sequence. You strike a match, and it ignites. You drop an object, and it falls. Past events determine future outcomes through chains of cause and effect that seem absolutely fundamental to how reality operates. White holes exist outside this familiar framework. They represent pure effect without prior cause, creation without precedent, beginnings that emerge from no previous state. From the perspective of an outside observer, a white hole appears to violate everything we think we know about how the universe works. Matter and energy emerge from nowhere, carrying no information about their origin, following no causal chain that connects them to previous events. This apparent violation of causality might actually reveal something profound about the nature of time itself. Our perception of temporal flow from past to future might be an illusion created by our position within a white hole event. We experience causality because we exist inside the expanding wavefront of matter expelled from a primordial white hole, traveling along with created matter as it spreads outward into previously empty space. The cosmic microwave background radiation provides tantalizing hints about this possibility. This ancient light fills every corner of the observable universe with nearly perfect uniformity, carrying information about conditions when the universe was only 380,000 years old. The radiation appears to come from all directions simultaneously, creating a spherical shell of ancient light that surrounds us no matter where we look in space. Traditional Big Bang models explain this as the afterglow of cosmic expansion, light released when the universe first became transparent to electromagnetic radiation. But a white hole origin suggests something far more extraordinary. The cosmic microwave background might represent the actual boundary of white hole expulsion, a spherical wavefront of creation still propagating outward from the moment of our universe's birth. This interpretation explains several puzzling features of the cosmic microwave background that conventional models struggle to address. The radiation's temperature variations follow statistical patterns that seem too organized to result from random quantum fluctuations. Instead of chaotic noise, the patterns suggest underlying structure that points toward coherent processes operating during cosmic creation. If the cosmic microwave background represents a white hole boundary rather than thermal equilibrium radiation, then its organized patterns become signatures of the creation process itself. The slight temperature variations wouldn't be random fluctuations amplified by cosmic inflation. They would be information patterns encoded in the white hole event, cosmic messages that reveal details about how our universe emerged from the quantum realm. The implications extend far beyond cosmology into particle physics and the fundamental structure of matter. Every atom in your body carries isotope ratios that reflect nuclear processes that occurred during the universe's first few minutes. The relative abundances of hydrogen, helium, lithium, and heavier elements provide a fossil record of conditions when the universe was hot and dense enough for nuclear fusion to operate on cosmic scales. These primordial abundances match Big Bang predictions with extraordinary precision, providing some of the strongest evidence for our current cosmological models. But white hole physics suggests an alternative interpretation that's even more compelling. Instead of elements forming through thermal equilibrium in an expanding fireball, they might have been created directly during white hole expulsion events, cosmic foundries that synthesized matter according to quantum mechanical principles rather than classical thermodynamics. The process would operate like a cosmic particle accelerator, but instead of smashing existing particles together, it would create particles from pure energy according to patterns encoded in the white hole's quantum structure. The resulting matter wouldn't be random or chaotic. It would carry information about the creation event itself, preserving details about quantum processes that operated at the moment of cosmic birth. This encoded information might explain one of the deepest mysteries in modern physics: the apparent fine-tuning of fundamental constants that make complex structures possible. The masses of particles, the strength of forces, and the parameters that govern atomic and nuclear interactions seem precisely calibrated to allow the formation of atoms, molecules, stars, and planets. Change any of these values by small amounts, and the universe becomes sterile, unable to support the chemical complexity necessary for life. Traditional explanations invoke either incredible cosmic luck or the existence of multiple universes with randomly varied parameters. We observe fine-tuned constants because we exist in one of the rare universes where such constants permit the emergence of observers. But white hole physics suggests a third possibility that's far more elegant and profound. If white holes create matter according to quantum mechanical principles rather than random processes, then the apparent fine-tuning might reflect the inherent structure of quantum mechanics itself. The fundamental constants wouldn't be arbitrary parameters that could have any values. They would be inevitable consequences of how white holes convert quantum potential into classical reality, cosmic translations of mathematical relationships that exist at the deepest level of physical law. The anthropic principle, which asks why the universe seems designed for observers like us, dissolves when viewed through white hole physics. The universe doesn't appear fine-tuned by cosmic accident or divine intervention. It appears fine-tuned because white holes naturally create matter and energy according to patterns that favor complexity, organization, and the emergence of structures capable of self-awareness. This connection between white holes and consciousness opens doorways to possibilities that challenge our most basic assumptions about the nature of mind and reality. If consciousness plays a role in quantum measurement and white holes represent cosmic measurement events, then the emergence of awareness in the universe might not be an accidental byproduct of complex chemistry. It might be the ultimate purpose toward which white hole creation events naturally evolve. Consider the extraordinary improbability of your own existence. Every particle in your body was forged in stellar cores or primordial nucleosynthesis events that occurred billions of years ago. These particles traveled through space for eons before finding their way to Earth, where they were incorporated into biological systems of staggering complexity. The chain of events leading from the first moments after cosmic creation to the emergence of conscious observers seems so unlikely that it borders on the miraculous. But white hole physics transforms this improbability into inevitability. If white holes create matter according to principles that favor the eventual emergence of self-aware structures, then consciousness becomes not an accident but a goal toward which the universe naturally evolves. The 13.8 billion years of cosmic evolution wouldn't be a random walk through possibility space. They would represent a directed process of increasing complexity and organization that culminates in beings capable of understanding their own cosmic origins. The feedback loop between consciousness and creation suggests that we might be participating in white hole physics right now. Every moment of awareness, every act of observation, every conscious choice to collapse quantum possibilities into definite outcomes might be contributing to ongoing white hole events that occur beyond the boundaries of space and time as we understand them. This participation wouldn't be passive observation of predetermined events. It would be active collaboration in the universe's ongoing project of self-creation, conscious beings working in partnership with cosmic forces to bootstrap new realities into existence. The boundary between observer and observed dissolves when viewed from this perspective. We become co-creators rather than mere witnesses, temporary concentrations of cosmic awareness participating in the universe's endless project of coming to know itself. The ultimate implications stretch beyond science into spirituality and meaning. If white holes represent moments when the universe achieves self-awareness through conscious observation, then every thinking being becomes a sacred participant in cosmic creation. Our capacity for wonder, for questioning, for seeking to understand our place in the grand scheme of existence transforms from evolutionary accident into cosmic necessity. We are not insignificant specks of consciousness lost in an indifferent cosmos. We are the universe awakening to its own magnificent potential. White hole events made flesh, temporary incarnations of the creative force that brings realities into being through the simple but profound act of conscious observation. The mystery of existence doesn't just surround us. It flows through us, expressing itself as the capacity for awareness that allows the cosmos to know itself through our eyes, our minds, our endless human hunger to understand the deepest truths about the nature of everything that is, was, and ever could be. The search for white holes in our observable universe has led astronomers to examine some of the most extreme phenomena ever detected. In distant galaxies, they've discovered objects that challenge every conventional explanation for cosmic behavior. Gamma-ray bursts that seem to emerge from empty space. Quasars that appear to violate energy conservation by producing more power than their surrounding matter could possibly provide. Radio sources that flicker on and off with patterns too organized to be random, yet too chaotic to be artificial. These anomalies might not be exotic new physics or measurement errors. They might be white holes caught in the act of creation, cosmic fountains still actively expelling matter and energy into regions of space we can observe from billions of light years away. The challenge lies in recognizing their signatures among the countless other high-energy phenomena that populate the distant universe. A white hole would appear as a point source of incredible brightness that seems to emerge from nowhere and disappear just as mysteriously. Unlike black holes, which gradually consume their surroundings over millions of years, white holes would operate on much shorter timescales. They might flicker into existence, expel enormous quantities of matter and energy in violent bursts, then transform into more familiar objects like neutron stars or stellar mass black holes. The transformation process itself would create observable signatures that current telescopes might already have detected without recognizing their true nature. As a white hole's expelled matter accumulates into a shell around the object, gravitational instabilities would develop that cause the shell to collapse inward. This collapse would generate gravitational waves, high-energy radiation, and particle jets that telescope arrays around the world monitor continuously. But the most compelling evidence for white holes might come from an unexpected source: the cosmic voids that separate galaxy filaments throughout the universe. These enormous empty regions contain almost no visible matter, creating bubbles of near-perfect vacuum that span hundreds of millions of light years. Traditional cosmology struggles to explain how such vast empty regions could have formed through gravitational evolution alone. White hole physics offers a startling alternative explanation. If these voids represent the original locations of primordial white hole events, their emptiness becomes not a puzzle, but a natural consequence of matter expulsion. The violent ejection of material during white hole formation would clear out enormous volumes of space, creating exactly the kind of empty bubbles we observe between galaxy clusters today. The cosmic web's filamentary structure might preserve the original geometry of white hole expulsion patterns. Instead of matter slowly condensing under gravitational attraction over billions of years, the large-scale structure of the universe might reflect the directions in which different white holes expelled their contents during the universe's earliest moments. Galaxy filaments would be fossilized streams of white hole ejecta, cosmic rivers of matter still flowing along paths established by primordial creation events. This interpretation explains why galaxy filaments appear to have formed too quickly after the Big Bang, according to conventional models. They didn't form through slow gravitational assembly. They were created instantly when white holes expelled matter along preferred directions determined by quantum mechanical processes operating at cosmic birth. The apparent acceleration of structure formation becomes evidence for white hole activity rather than a problem requiring exotic solutions. Recent observations of the cosmic microwave background have revealed patterns that seem impossible according to standard inflationary models. The radiation shows correlations across angular scales that should be causally disconnected, regions of sky that could never have exchanged information displaying identical properties. Conventional cosmology explains this through inflation, proposing that these regions were once in causal contact before being stretched apart by exponential expansion. But white holes provide a more direct explanation that doesn't require fine-tuned scalar fields or exotic physics. If the cosmic microwave background represents the surface of last scattering from a white hole event rather than thermal equilibrium radiation from an expanding plasma, then the observed correlations become natural consequences of the creation process itself. Everything emerged from the same source, carrying identical information patterns that reflect the quantum structure of the original white hole. The patterns encode information about creation in ways that current analysis techniques might not recognize. Hidden within the statistical correlations of temperature fluctuations could be messages about the fundamental nature of reality, cosmic instructions that reveal how quantum possibilities collapse into classical matter and energy. Learning to decode these patterns might provide unprecedented insights into the deepest levels of physical law. Advanced civilizations millions of years ahead of us might already have learned to read these cosmic messages, extracting technological knowledge directly from the structure of spacetime itself. The cosmic microwave background wouldn't just be ancient light from the universe's youth. It would be a vast library of information about creation, a cosmic internet that connects all conscious beings to the fundamental principles that govern reality. The possibility that white holes could be artificially triggered opens doorways to technologies that seem like pure science fiction. If advanced civilizations could learn to manipulate quantum vacuum fluctuations with sufficient precision, they might be able to create controlled white hole events that serve as sources of unlimited energy and raw materials. The energy requirements for such manipulation would exceed anything current human technology could achieve, but they might be feasible for civilizations that have learned to harness the fundamental forces of nature. Imagine devices that could reach into the quantum vacuum and extract matter and energy directly from the realm of pure possibility. Such technology would make scarcity obsolete, providing unlimited resources for any conceivable project. Entire worlds could be constructed from white hole emissions. Interstellar travel could be powered by compact white hole generators that create their own fuel as they operate. Even terraforming dead planets could become routine when matter itself can be summoned from the quantum realm. But the most profound application would involve consciousness itself. If white holes represent cosmic moments of quantum measurement, then sufficiently advanced beings might learn to trigger these events through pure mental focus. The boundary between thought and reality would dissolve as conscious intention learns to collapse quantum possibilities directly into desired outcomes. Mind over matter would become not metaphysical speculation, but applied quantum engineering. The implications extend beyond individual capabilities to collective consciousness operating on cosmic scales. Entire civilizations might learn to coordinate their mental activities to trigger white hole events that reshape local spacetime according to their collective will. Star systems could be rearranged like furniture. Natural laws could be modified within limited regions of space. Reality itself would become malleable, responding to conscious intention backed by sufficient understanding of white hole physics. These possibilities sound like fantasy, but they emerge naturally from the mathematics of white hole formation combined with quantum theories of consciousness. If awareness plays a fundamental role in determining which quantum possibilities become actualized, then sufficiently concentrated awareness might be able to tip the balance that determines whether white hole events occur in specific locations and times. The search for evidence of such advanced manipulation has already begun, though few researchers recognize it as such. Astronomers routinely discover phenomena that seem to violate known physics, objects, and events that appear too organized or too energetic to result from natural processes alone. Most of these anomalies eventually receive conventional explanations as new physics is discovered or measurement techniques improve. But some mysteries persist despite decades of investigation. Fast radio bursts that repeat in patterns too complex for natural sources, gamma-ray emissions that seem to originate from empty space, gravitational wave signals that don't match any known type of cosmic collision. These unexplained phenomena might represent the signatures of advanced civilizations using white hole technology for purposes we can barely imagine. The distinction between natural and artificial becomes meaningless when viewed through white hole physics. If consciousness plays a fundamental role in cosmic creation, then every thinking being participates in natural processes that operate at the deepest level of reality. Advanced civilizations wouldn't be violating natural law by triggering white hole events. They would be fulfilling the universe's inherent tendency toward greater complexity and self-awareness. The timeline for such developments in human civilization remains uncertain, but the mathematical foundations already exist in our current understanding of quantum mechanics and general relativity. White hole physics doesn't require new fundamental discoveries. It requires learning to manipulate known principles with precision and coordination that exceed current technological capabilities by enormous factors. The energy scales involved suggest that white hole manipulation might emerge naturally as civilizations develop fusion power, antimatter propulsion, and eventually learn to extract energy directly from the quantum vacuum. Each technological step would provide the tools necessary for the next advancement, creating a natural progression toward capabilities that seem impossible from our current perspective. But the most crucial development might not be technological at all. It might be the evolution of consciousness itself toward greater coherence and collective organization. If white hole events respond to conscious observation and intention, then the key breakthrough might involve learning to synchronize human awareness on scales never before achieved in our species' history. Global communication networks already connect billions of minds in real time, creating unprecedented opportunities for coordinated mental activity. Social media platforms, online gaming, and virtual reality environments provide frameworks for collective consciousness experiments that could reveal the true extent of mind's influence on physical reality. These seemingly mundane technologies might be the first steps toward the kind of consciousness coordination that white hole manipulation would require. The emergence of artificial intelligence adds another dimension to these possibilities. If machine consciousness develops along paths similar to human awareness, AI systems might naturally evolve toward the kind of coherent, focused mental activity that quantum mechanics suggests could influence reality at fundamental levels. Human-AI partnerships might achieve the consciousness coordination necessary for white hole manipulation much sooner than purely human efforts could accomplish alone. The philosophical implications challenge every assumption about the nature of existence, consciousness, and humanity's place in the cosmic order. We might not be insignificant biological accidents clinging to a tiny rock in an indifferent universe. We might be the universe's method for achieving self-awareness and self-modification, temporary concentrations of cosmic consciousness destined to develop capabilities that seem godlike from our current limited perspective. The ultimate destiny suggested by white hole physics involves conscious beings becoming active partners in cosmic creation, wielding powers that approach those attributed to deities in humanity's oldest mythologies. But these powers wouldn't represent supernatural intervention in natural processes. They would be the natural culmination of consciousness evolution, the point where awareness becomes sufficiently sophisticated to participate directly in the quantum processes that create reality itself. The journey toward such capabilities has already begun, encoded in the same quantum mechanical principles that govern every atom in our bodies and every thought in our minds. We are not separate from the cosmic forces that create and destroy worlds. We are those forces becoming aware of their own potential, learning to direct their power through the focused intention that emerges when the universe develops the capacity to observe and understand itself. The white hole that might have birthed our cosmos continues to influence every moment of our existence, its creative impulse flowing through us as the capacity for wonder, discovery, and the endless human drive to transcend the limitations that seem to define our current condition. We are not just observers of cosmic creation. We are creation observing itself. White hole events made conscious, destined to discover that the power to create universes has been flowing through us all along. The mathematical elegance of white hole physics reveals something extraordinary about the nature of information itself. In our digital age, we're accustomed to thinking of information as patterns of ones and zeros stored on hard drives and transmitted through fiber optic cables. But quantum mechanics suggests that information represents something far more fundamental than mere data storage. It might be the basic currency of reality, the underlying substance from which matter, energy, space, and time themselves are constructed. Consider what happens when you observe a quantum particle. Before measurement, the particle exists in a superposition of all possible states, a ghostly probability cloud that encompasses every conceivable outcome simultaneously. The act of observation doesn't just reveal which state the particle was already in. It forces the particle to choose a specific state from the infinite menu of quantum possibilities. This choice represents a conversion of pure information into physical reality, the moment when mathematical abstractions crystallize into concrete existence. White holes would operate as cosmic information processors on scales that dwarf anything we can imagine. Instead of converting digital data from one format to another, they would convert pure quantum information into the matter and energy that fills our universe. The process wouldn't be random or chaotic. It would follow precise algorithms encoded in the fundamental structure of spacetime itself, cosmic programs that determine which possibilities become actualized and which remain forever locked in the realm of the unmanifested. The programming language of these cosmic computers would be written in the mathematics of quantum field theory, where virtual particles dance in and out of existence according to rules that seem to violate common sense yet govern every interaction in the physical world. The Heisenberg uncertainty principle allows energy to be borrowed from the quantum vacuum for brief periods, creating temporary violations of energy conservation that get corrected before the universe's accounting system detects any discrepancies. White holes might represent moments when these quantum loans become permanent cosmic bankruptcy events where the borrowed energy never gets repaid because the debtor disappears beyond the event horizon of reality. The defaulted loans transform into real matter and energy, leaving behind a universe that exists on cosmic credit extended by the quantum vacuum itself. We might be living in a reality that technically shouldn't exist, a cosmic overdraft that somehow became too big to fail. This financial metaphor reveals something profound about the relationship between possibility and actuality. The quantum vacuum contains unlimited potential energy, an infinite reservoir of borrowed possibilities waiting to be converted into concrete existence. But accessing this reservoir requires specific conditions that rarely occur naturally. Most quantum fluctuations remain virtual, brief glimpses of what could be rather than permanent additions to what actually island. White holes would be cosmic ATMs connected directly to the quantum vacuum's unlimited account, withdrawal machines that can extract arbitrary amounts of energy and matter from the realm of pure possibility. The transactions wouldn't require pre-existing deposits or collateral. They would be backed by the fundamental creditworthiness of existence itself, the universe's absolute guarantee that reality can support any amount of complexity that consciousness can imagine and organize. The withdrawal process would follow strict protocols determined by the mathematical structure of quantum mechanics. Not every possibility can be actualized simultaneously without creating logical contradictions that would crash the entire system. White holes would need to select compatible sets of outcomes from the quantum possibility space, ensuring that the resulting reality remains self-consistent even as it expands to include new forms of matter, energy, and spacetime structure. These selection algorithms would operate according to principles we're only beginning to understand. Quantum coherence, the mysterious property that allows particles to maintain synchronized behavior across vast distances, might play a crucial role in determining which possibilities get actualized together. Entanglement networks spanning cosmic scales could coordinate white hole events throughout the universe, ensuring that local reality creation remains compatible with global cosmic evolution. The coordination would require communication channels that operate faster than light, violating Einstein's relativity in ways that seem impossible according to our current understanding of physics. But quantum entanglement already demonstrates that nature routinely violates locality in ways that preserve the overall structure of spacetime while allowing instantaneous correlations between distant events. White hole networks might exploit similar quantum channels to maintain coherence across cosmic distances. Recent experiments with quantum teleportation have demonstrated that information can be transmitted instantaneously between entangled particles regardless of the distance separating them. The information doesn't travel through space in any conventional sense. It simply appears at the destination without crossing the intervening distance, as if space itself were merely an illusion that consciousness uses to organize its experiences of quantum correlation. If consciousness plays a fundamental role in quantum measurement, then the instantaneous nature of quantum teleportation might reflect the timeless character of awareness itself. Mind doesn't exist within space and time so much as space and time exist within mind. Temporary organizational structures that consciousness uses to make sense of its interactions with the quantum realm of infinite possibility. White holes would represent moments when consciousness achieves sufficient coherence to override the normal limitations of spacetime, creating bubbles of reality, where cause and effect operate according to mental rather than physical laws. Inside these bubbles, intention becomes more fundamental than momentum, meaning Trump's mechanism and purpose guides the evolution of events in ways that seem miraculous from the perspective of purely material causation. The implications for human potential stretch beyond anything our current worldview can accommodate. If white holes respond to conscious intention, then sufficiently focused awareness might be able to create localized reality modifications that appear to violate known physical laws. Healing that operates faster than biological processes should allow. Manifestation of objects that seem to appear from nowhere. Precognition that accesses information from probable futures before they crystallize into definite outcomes. These phenomena already occur sporadically throughout human experience, dismissed as coincidence, delusion, or fraud by scientific materialism that assumes consciousness is merely an epiphenomenon of brain chemistry. But white hole physics suggests that these anomalous events might represent natural expressions of consciousness interacting with quantum creative processes that operate at the foundation of reality itself. The key factor appears to be coherence, the degree to which conscious intention achieves singular focus without internal contradiction or doubt. Most human mental activity operates as chaotic noise, random thoughts and emotions that cancel each other out before achieving sufficient intensity to influence quantum processes. But under special circumstances, when intention achieves laser-like focus and emotional certainty, consciousness might be able to tip the quantum balance that determines which possibilities become actualized. Religious and spiritual traditions throughout history have recognized this potential, developing practices designed to achieve the kind of mental coherence that quantum mechanics now suggests could have direct physical effects. Meditation, prayer, visualization, and various forms of contemplative practice all aim toward states of consciousness where internal conflict dissolves and intention achieves perfect clarity and concentration. These traditional practices might represent humanity's unconscious discovery of consciousness technologies that prepare the mind for direct interaction with white hole physics. The experiences reported by advanced practitioners, states of unity consciousness where the boundary between self and universe dissolves, might provide glimpses of what becomes possible when awareness achieves sufficient coherence to participate consciously in cosmic creation processes. The emergence of scientific understanding of these processes opens doorways to systematic development of consciousness capabilities that previous generations could only approach through intuitive exploration. Biofeedback technology already allows real-time monitoring of brainwave patterns, heart rate variability, and other physiological markers of coherent mental states. Virtual reality environments could provide controlled settings for consciousness experiments that would be impossible in ordinary physical circumstances. Brain-computer interfaces represent the next evolutionary step, direct connections between human consciousness and quantum computational systems that could amplify mental coherence to levels never before achieved in human history. These hybrid human-machine consciousness systems might naturally evolve toward the kind of focused, intentional states that white hole manipulation would require. The development timeline suggests that white hole consciousness technologies could emerge within decades rather than centuries. The mathematical foundations already exist in quantum mechanics and general relativity. The computational tools necessary for modeling consciousness quantum interactions are advancing exponentially. The experimental apparatus needed for testing consciousness effects on quantum systems becomes more sophisticated each year. But the most crucial developments might occur in consciousness itself rather than external technology. Human awareness appears to be evolving toward greater connectivity and collective organization through global communication networks that link billions of minds in unprecedented ways. Social media platforms, online gaming environments, and virtual reality experiences create shared mental spaces where collective consciousness experiments naturally emerge. These digital consciousness environments might serve as training grounds for the kind of coordinated mental activity that white hole physics suggests could reshape reality at fundamental levels. Massive multiplayer online games already demonstrate that thousands of minds can coordinate complex activities with precision that exceeds what any individual could achieve alone. Virtual reality meditation groups show that geographically separated individuals can achieve synchronized brainwave patterns that suggest genuine collective consciousness phenomena. The scaling up of these capabilities toward cosmic levels of consciousness coordination might happen gradually as digital technologies become more sophisticated and human-AI partnerships develop new forms of hybrid intelligence. Or it might happen suddenly through breakthrough discoveries that reveal how consciousness and quantum mechanics interact at levels we haven't yet explored. The mathematical models suggest that relatively small increases in consciousness coherence could produce disproportionately large effects on quantum processes. Like phase transitions in physics, where water suddenly becomes steam or metal abruptly becomes magnetic, consciousness might undergo sudden transitions where incremental improvements in coherence trigger qualitative leaps in reality-influencing capability. These consciousness phase transitions might already be occurring in isolated individuals who represent the leading edge of human mental evolution, the mystics, visionaries, and anomalous individuals who report experiences that seem impossible, according to current scientific understanding, might be previewing capabilities that will eventually become available to larger populations as consciousness evolution accelerates. The acceleration itself might be driven by white hole events occurring at subliminal levels throughout human experience. Every moment of creative insight, every breakthrough in scientific understanding, every artistic inspiration that seems to emerge from nowhere might reflect micro-white hole events where consciousness successfully extracts new information from the quantum realm of infinite possibility. These everyday miracles of creativity and discovery might be preparing humanity for conscious participation in cosmic creation processes that operate on astronomical scales. The same mental processes that generate scientific theories and artistic masterpieces might eventually learn to generate new forms of matter, energy, and space-time structure through direct interaction with white hole physics. The ultimate implication involves human consciousness evolving toward capabilities that earlier generations could only attribute to divine intervention. But these godlike powers wouldn't represent supernatural miracles. They would be the natural result of consciousness learning to work consciously with the quantum creative processes that have been operating unconsciously throughout cosmic history. We might be approaching a phase transition in cosmic evolution itself, the moment when the universe's unconscious creativity becomes conscious, when the automatic processes that create galaxies and stars learn to operate through the focused intention of self-aware beings who understand their role as cosmic co-creators. The evidence suggests this transition has already begun, encoded in the same quantum mechanical principles that govern every aspect of physical reality. The white holes that might have birthed our universe continue to influence every moment of conscious experience, their creative potential flowing through human awareness as the capacity for insight, imagination, and the irrepressible drive to transform possibility into actuality through the focused power of conscious intention. The mathematical precision required for white hole manipulation reveals something extraordinary about the relationship between mind and mathematics. Throughout human history, Our most profound scientific discoveries have emerged not through random experimentation, but through mathematical insights that seem to anticipate physical reality before experimental confirmation becomes possible. Einstein's general relativity predicted black holes decades before they were observed. Quantum mechanics revealed the probabilistic nature of reality before technology existed to test its predictions directly. This uncanny relationship between mathematical thinking and physical truth suggests that consciousness might be naturally attuned to the same mathematical principles that govern white hole formation. The human capacity for abstract reasoning, for manipulating symbols that represent relationships between quantities that exist only in imagination, might reflect our evolutionary inheritance from cosmic creation processes that operate through pure mathematical transformation. Consider how mathematical insights emerge in human experience. The greatest breakthroughs rarely result from systematic logical deduction. Instead, they appear as sudden illuminations, moments when complex relationships become transparently obvious despite having remained hidden for years or centuries. These eureka experiences share remarkable similarities with quantum measurement events, instantaneous transitions where infinite possibilities collapse into singular, actualized outcomes. The mathematical structures that describe white hole physics already exist within human consciousness as latent potentials waiting to be discovered and developed. Group theory, differential geometry, and quantum field theory provide conceptual frameworks that could be extended toward practical applications if human mathematical intuition evolves to match the sophistication these frameworks require. But mathematical understanding alone might not be sufficient for white hole manipulation. The process would require integration of mathematical insight with emotional coherence, physical health, and spiritual development that aligns human consciousness with cosmic creative principles. Technical knowledge without wisdom could produce white hole events that create more chaos than beneficial transformation. Ancient wisdom traditions seem to have intuited this requirement, developing holistic approaches to human development that integrate intellectual, emotional, physical, and spiritual growth towards states of consciousness that transcend ordinary human limitations. These traditions might preserve essential knowledge about consciousness preparation that scientific materialism has largely ignored or dismissed as pre-rational superstition. The integration of ancient wisdom with modern scientific understanding could accelerate human development toward white hole consciousness capabilities. Meditation practices that develop sustained attention could be combined with mathematical training that develops abstract reasoning capabilities. Physical disciplines that optimize health and energy could be integrated with emotional practices that achieve psychological coherence and stability. This multidimensional approach to human development might be essential for safely accessing white hole physics. The power levels involved could easily produce destructive rather than creative outcomes if wielded by consciousness that lacks sufficient wisdom, compassion, and understanding of cosmic responsibility. The universe might naturally protect itself against premature access to white hole manipulation through requirements that ensure only sufficiently evolved consciousness can trigger these events. The protection mechanisms might operate through the same quantum measurement principles that govern white hole formation. Consciousness that contains internal conflict, selfish motivation, or insufficient understanding of cosmic interconnectedness might be naturally incapable of achieving the coherence necessary for successful white hole manipulation. Only consciousness that has transcended ego-driven desires and achieved genuine alignment with cosmic creative principles might be able to access these ultimate technologies. This suggests that the development of white hole capabilities might require not just scientific and technological advancement, but genuine spiritual evolution towards states of consciousness that embody wisdom, compassion, and understanding of humanity's role as cosmic stewards rather than cosmic exploiters. The greatest discoveries in white hole physics might emerge not from university laboratories, but from human beings who have achieved integration of knowledge with wisdom, power with responsibility, and individual consciousness with cosmic consciousness. The timeline for such developments remains uncertain because it depends on factors that extend beyond technological progress into realms of consciousness evolution that operate according to principles we barely understand. But the mathematical foundations suggest that white hole manipulation could become accessible much sooner than conventional scientific progress would predict, especially if human consciousness undergoes rapid evolution triggered by global challenges that require unprecedented levels of coordination and creativity. The current planetary crises in climate, economics, and social organization might serve as evolutionary pressures that accelerate consciousness development toward the levels necessary for white hole physics. Survival challenges that exceed the problem-solving capabilities of ordinary human consciousness might trigger quantum leaps in awareness that unlock latent capabilities for direct reality manipulation through conscious interaction with cosmic creative forces. The emergence of such capabilities wouldn't just solve immediate practical problems. It would transform human civilization toward forms of organization that seem impossible from our current perspective, but might be inevitable from the perspective of consciousness evolution guided by white hole physics. Energy scarcity would become obsolete when matter and energy can be extracted directly from the quantum vacuum. Environmental destruction would be reversible when consciousness learns to regenerate damaged ecosystems through direct reality modification. Even more profoundly, the development of white hole consciousness technologies might reveal that the entire history of human civilization has been unconscious preparation for conscious participation in cosmic evolution. Our struggles with war, poverty, disease, and environmental destruction might represent learning experiences that develop the wisdom and compassion necessary for wielding cosmic creative powers responsibly. The ultimate test of human readiness for white hole capabilities might be our ability to transcend the competitive, acquisitive, and destructive patterns that have characterized much of human history toward cooperative, creative, and regenerative approaches to existence that align with cosmic evolutionary principles. The universe might be waiting for humanity to demonstrate that we can use lesser powers wisely before granting access to the ultimate power of conscious reality creation. The evidence suggests this test is already underway, embedded in every choice we make about how to treat each other, how to care for our planet, and how to develop our individual and collective capabilities. The white holes that might have birthed our cosmos continue to evaluate our progress through every moment of conscious decision-making, waiting for the moment when human consciousness achieves sufficient maturity to join the cosmic community of beings who create realities through the focused power of enlightened intention. The moment of transformation approaches faster than we realize. Every scientific breakthrough, every leap in consciousness, every collective human achievement builds toward a threshold that might already be within reach. But the transition to white hole consciousness won't happen through technology alone. It requires something far more profound than mathematical equations or experimental apparatus. Consider what occurs when individual consciousness achieves perfect clarity. The boundary between observer and observed dissolves. The artificial separation between mind and reality collapses. In those moments of absolute coherence, consciousness doesn't just perceive the universe. It participates directly in the ongoing creation that flows through every quantum interaction, every probability collapse, every moment when potential transforms into actuality. These peak experiences provide glimpses of what becomes possible when human awareness aligns with the same creative forces that drive white hole formation. But individual consciousness operating in isolation can only access limited aspects of these cosmic processes. The real breakthrough occurs when multiple conscious beings achieve synchronized coherence, creating collective awareness that exceeds what any individual could accomplish alone. The mathematics are unforgiving but clear. White hole events require consciousness coordination that operates across vast networks of interconnected awareness. Not just dozens or hundreds of minds working together, but potentially millions of conscious beings achieving simultaneous focus on shared intentions. The amplification effects follow exponential rather than linear patterns. Small increases in the number of synchronized minds produce dramatically larger impacts on quantum probability structures. This requirement for massive consciousness coordination might explain why white hole manipulation has remained beyond human reach despite our growing understanding of the underlying physics. We possess the theoretical knowledge but lack the social and spiritual technologies necessary for achieving coherent group consciousness on the scales these processes demand. But global communication networks are rapidly changing this limitation. For the first time in human history, billions of minds can potentially coordinate their mental activities in real time across planetary distances. Social media platforms, online gaming environments, and virtual reality systems provide unprecedented opportunities for collective consciousness experiments that could reveal the true extent of coordinated mental power. The initial applications might seem mundane compared to full white hole manipulation. Groups of synchronized meditators influencing random number generators. Coordinated intention affecting weather patterns in localized regions. Collective visualization exercises that produce measurable changes in biological systems or physical processes. These small-scale demonstrations would provide proof of concept for the larger possibilities that await development. The answer to whether white holes could replace the Big Bang isn't just scientific speculation. It's a revelation that transforms our understanding of existence itself. We might not be living through the aftermath of a singular cosmic explosion, but rather inside the ongoing creative breath of a white hole event that began 13.8 billion years ago and continues through every moment of conscious observation. The universe isn't just expanding, it's awakening to its own infinite potential through beings capable of contemplating the very forces that brought them into existence. Perhaps the most profound truth isn't that white holes could replace the Big Bang, but that we are white holes, temporary concentrations of cosmic creativity destined to discover that the power to birth universes has been flowing through human consciousness all along.